All right, this is our introduction to conics, and there are 4 conics that we're going to be looking at. The first one is called a parabola. You've seen a parabola before, but when we're talking about it in conics, we look at it a little differently. The equation you need to be most familiar with is the vertex form, which is y equals parentheses x minus h quantity squared plus k. That's your vertex form. A parabola is defined by 2 things. It's defined by its focus, and it's defined by this thing called the directrix. And if you're looking at a picture of a parabola, there's this focus here. There's a little directrix down here. Now, neither one of those things you can see when you're actually graphing the parabola. All right? But the cool thing is this vertex business right here, this vertex right here, all right, it's exactly the same different distance from the focus to the vertex as from the vertex to the directrix. And that's true for every single point on the parabola. Every point on the parabola is equidistance focus to directrix, even though it doesn't look like it in this picture. That's the definition of a parabola. The collections of all points that are equidistant from a focus and a directrix. Okay? Let's see. So that's our first kind. Second kind of conic is going to be called a circle. And you know what a circle is. A circle is just a collection of points that are equidistant from a center. And this distance from the center to where the circle is, that's called your radius, right? Mm-hmm. Okay? So the circle doesn't actually include the center. It doesn't actually include the radius, but we use the center and the radius to mathematically define what our circle is. It's the collection of all those points. Let's see if I've got... Here is your general equation for a circle. It's x minus h quantity squared plus y minus k quantity squared equals r squared. Now, h and k here, that would be your center. Just like h and k was your vertex up here, all right? R just stands for your radius. If you're looking at a circle that's centered at 0, 0, it just looks like x squared plus y squared equals r squared. So it looks a lot like the Pythagorean theorem if your circle were centered at 0. Mm-hmm. Which is kind of cool to think about. You got this triangle going on, right? Mm-hmm. And it's this point, but it's all this point. Okay. All right, so those are 2 of our conics. Our third conic is going to be what's called an ellipse. Ellipse. Now this is different than the ellipses that they use in English. I don't really remember what those are, so we're not even going to go there. So your general form of an ellipse is going to be the following. It is going to be x minus h quantity squared over a squared minus, no, plus. It's plus. Y minus k quantity squared over b squared, and it's going to equal 1. All right. Now, let me just kind of show you a picture of an ellipse. It kind of looks like a football, only not quite. There are 2 pieces in there. Okay, this nose-looking thing, that would be your center. The 2 eyeball-looking things, those would be your foci. Okay? And then these little parts here. Okay, your ellipse can go 2 different directions. If it's kind of longer on this side, this is called a horizontal major axis because it's longer that way than it is this way. Mm-hmm. Okay? And this distance across here, what is that, 2A? This whole thing is 2A. The major axis is from one end to the other, and major axis is equal to 2A. This would be my minor axis from like down here to through here, through the center. See this? Mm-hmm. That whole thing would be 2B. Minor axis is 2B. So let's just kind of think this. Let me use different colors. Let's get color coordinated. Woo-hoo. Okay. This whole thing from right there to the center, that's going to be your distance A. Are you kind of seeing that?
Mm-hmm.
Okay. This little bitty distance is B. All right. And we're going to get super color coordinated here. And this little thing here, that little distance from your center to your focus, is C. Are we okay with that?
Mm-hmm.
Now C is equal to this, and you're going to want to know this. Actually, C squared is equal to A squared minus B squared. And you just need to know that for all ellipses. And we're going to get into more on conics for each individual one. This is just an overview of each one.
Okay.
All right? So let's see. We did, first was parabolas, second was circles, third is ellipses, and fourth is going to be what are called hyperbolas. Can I erase this?
Mm-hmm. Yes.
Okay. So let's look at hyperbolas. Very, very similar. The fourth type is called a hyperbola. Okay. All right. Okay. Now, the general equation for your hyperbola is going to look like this. It's very similar to your ellipse. It's going to look like x minus h quantity squared all over a squared. And remember how we had a plus for ellipses? This is going to be a minus in between. Minus y minus k quantity squared. Whoops. Over b squared equals 1. Now, this right here, in this case, would be my center on this one. All right, the distance from the center to the vertex, because that would be kind of like a vertex. Would we call that a vertex, or would we call that? Yes, we would call it a vertex. That's going to be A. So this is the same distance here, A. I didn't draw these in, but they do have a foci. Each one is inside the curve. And the distance from the vertex to the focus is C. So this little distance in here is C. This little distance in here is C. Or am I wrong on that? Hold on. Nope. This whole distance is C. From the center to the focus. My bad. Okay. Now, if I were to draw a box that had like asymptotes, which this does, this curve stays inside these asymptotes and never touches it, but it gets mighty close. And you were to take this kind of thing like here. Okay.
Mm-hmm.
This length here, that's your 2A, right? The length of the major axis kind of thing.
Mm-hmm.
This height here would be 2B. Okay. So this height here is just going to be B for this, just this half, and then the other half would be B as well. And in this case, C has a different equation. C squared is equal to A squared plus B squared. So your C, you find C differently for hyperbolas and ellipses. And I know it seems like a lot of information, but today we're hopefully going to focus on circles and parabolas for you guys.
Okay.
Okay? We can kill that.